And lastly, I will introduce the next two things of PyHealth. The first one is this trainer. So this trainer is very similar to those PyTorch Lightning framework or the trainer provided by Hugging Face transformers. So the main difference is that in our trainer, we try to make it more lightweight, flexible, and more easy to use without too many complex functionalities. So the main features of this trainer includes auto logging, checkpoint saving, and metrics monitoring. So to initialize the trainer, you essentially need to input the models you want to train using this trainer here, and then give the corresponding data loader, training loader, validation data loader, and some other hyperparameters for the training process, including epochs and the metrics you want to monitor. And this trainer will do the training for you automatically. And the output of this trainer is a folder who's named by the time and date that you run this trainer or any custom experiment you design. And it will include the following three files. The best model parameters from this whatever metric you monitor, and the last model parameters in the final training step, and also a logging file, including very detailed logging of the entire training process. So it will include the model architecture and the metrics, whatever training hyperparameters you are using, including batch size, optimizers, and some other hyperparameters, and also the metrics you monitor for each of the epoch, as you can see here. Next, I will go over the PyHealth trainer. So this trainer handler is very similar to the PyTorch Lightning trainer or the Hugging Face transformers trainer, except that this trainer is more like a minimalized version and it's more lightweight and easy to use. So to use this trainer, you need to first initialize a trainer instance with the following arguments, including the model and the checkpoint path you want to store the model, and some other arguments such as the metrics you want to monitor, the device you want to store the model, and some other utility arguments. And to train a model, you need to run this trainer.train, which will start to train the deep learning model. And this trainer.train has the following arguments, including the data loader, some hyperparameters such as epochs, optimizer, learning rate, rate decay, gradient norm, and also the metric you want to monitor and whether it is the higher the better or the lower the better, and whether you want to load the best model last. Here we use the same dataset, this Mimic3 synthetic dataset, and then we have to set this task to create a sample dataset and do the train validation split, and then get a corresponding loader using this sample dataset. And then we will initialize the model. So that's shown in our previous Colab notebook. And to initialize the trainer, we just set the models to the model we just initialized and keep all the arguments by default. And then we want to start the model training, where we input the train loader, validation loader, and set the epochs to be 50. And here, since it is a binary classification task, we will monitor the RCUC score. So after the training, the trainer will create a output folder and inside this output folder, there will be a different folder for each training session. As you can see here in this training session, the trainer created 3 files. The first 2 files are the checkpoint files, which include the model parameters of the best model and also the last model. And the third one is this logging file, which essentially record the entire training session. It includes the model architecture, the hyperparameters, and also the training progress, the training loss, and evaluation metrics.